members are looking to build and grow into a 1 to 5, maybe even larger megawatt site. So today we're going to be focusing specifically on the 1 to 5 range, trying to keep that in mind. Nobody here is building a 50 megawatt site at this moment. So we'll keep it kind of down to there. But what I encourage the community to do is to think about some questions that you might have for Ethan and for Jason, so that at the end of this call, we can actually facilitate some of those questions. Ethan and Jason can both answer how they see fit. The way that we're going to do this today is it's going to be kind of like a podcast. I'm going to ask Ethan and Jason a couple of questions that kind of help move the conversation along. And I just want to get into kind of the nitty gritty between transformers, what's before the meter, what's after the meter. We want to talk about all the different things, the components of the electrical infrastructure required to build out your site. And like I said, if you guys have any questions, feel free to put them in the chat. We'll answer them when we get to the end, or just raise your hands. Definitely want to get that answered. So before we do that, I want to give a little bit of an introduction for who we have here. So Ethan Ellenberg is the CEO of Moonshot. Moonshot specializes in designing and manufacturing advanced modular data centers, custom electrical panels, and distributing a wide range of transformers. We also have Jason. Jason is the CEO of Hillfort. Hillfort is a mining equipment and electrical infrastructure procurement company. Most of you will remember Jason from last month when he came and gave a presentation on how to build a hosting facility. So Jason's very well knowledgeable, and so is Ethan on electrical data centers, infrastructure, all that good stuff. So we have two, home runners in the park today, and we're super excited about it. So, Jason, if you want to just give a short introduction, anything beyond what I've already given, and then we'll give Ethan a short second to do the same.
Yeah, so essentially at Hillfort, what we do is our goal is to advise our clients on purchasing, everything they need for their operation. So from transformers all the way down to the actual miners to power cables, we're pretty much everything from A to Z we can handle in-house. If we don't have it, we have great people that we work with. I don't know if I've referred anyone to Ethan yet, but I know I'm going to. And I mean, I've seen their work in the past, but basically we're just a procurement firm. So all the kind of EPC nitty gritty that you need done, we either know someone that can do the engineering, and we can get you in touch with them, or we can handle everything else. So that's where we fit in the space pretty well, and excited for this.
Awesome. Thank you, Jason. Ethan?
Yeah, I'll tell you a little bit about how I got started doing this, because it's kind of a fun story. But so my background's oil and gas, mechanical engineering background, and I was in oil and gas for 8 years. And in 2020, ended up getting laid off, moved over to data centers. We started getting some requests to build out some curtailment software. We were doing building controls for hyperscale data centers. And around that time, I know we're Bitcoin guys, but Elon Musk said buy Doge, and so I did. I put $500 in Doge, and $500 turned into $50,000 in about 3 months. And then I bought some SHIB, and I think my portfolio was $175,000. And I was like, all right, there's something to this. And then China banned Bitcoin mining, and so I was like, I want to mine Bitcoin. I'm going to do 5 megawatts. And so I reached out to a company you may have heard of called Compute North, who is no longer around. But I said, hey, can you give me 5 megawatts? They said, yeah. And a couple months go by, they couldn't give me a contract. I was like, where's my contract? And they go, well, we have the power, we don't have the pods. I said, how many pods do you need? They said 1,000. And so we were integrating our controls into the pods, and they told me they paid $500,000. So I plugged that in my calculator. I was like, $500 million, I'll build your pods. And so that's how we started. And so I was subcontracting out engineering and subcontracting out manufacturing. And then people started requesting electrical panels. And we realized that the subcontractors didn't always do it to our standards. And so we went out and we got our own UL certification. So we are a UL 508A industrial control panel, UL 67 panel board, and a UL 891 switchboard panel shop. And so that's our primary focus. We do custom racks. We just did we're still in the middle of a 200 megawatt air-cooled building where we designed and provided all of the fan walls, controls. We did over 2 miles of 24-foot tall racks that we designed. And then we are about to be awarded another 200 megawatt project that's hydro cool. So but we've done everything from the 1 megawatt guy in his on his farm looking to do a small little operation up to 200 megawatt facilities.
Well, that is quite the background, Ethan. That's you've done a lot. To go from $500 to where you are now is a testament to what can happen in the space, and it moves quickly. But that's an amazing story.
Yep, absolutely.
Well, so let's just jump into this. I want to use our time today to help our audience understand what is required for electrical infrastructure. We want to kind of stay on the side of profitable, efficient, and safety. So I know a lot of things you can skip, a lot of things you can kind of not do correctly and still run an operational mine. Let's not focus on that today because we're trying to specifically focus on safety and efficiency. So I want to start with, and Ethan, Jason, whichever one of you wants to go off on this first, I want to start with what is the components before the meter and what are the components after the meter, and how does that look like for somebody who's just, let's say they've got a green field, they've got a, electric pole sitting in the green field. How do they go from, I've got this pole sitting in the green field, I have power, quote unquote, to actually being able to put, the transformer on the pad, get the switch gear and everything else in the space?
You want to go, Jason? If not, I'll take
I mean, okay, so everything before the transformer, and that's the high size. That's gonna be your 12,470, your 13,800 volt. That is going to depend solely, and this is not me having a cop-out answer. It's going to depend completely on what the electric company says. You have no control over that. Now, if you're building 200 megawatts, I'm sure you have more flexibility. But your 5 megawatt site, let the expert that's been at the power company for 10 years or more handle it. Now you need to make sure that they know the load's very, very consistent. You need to make sure they scale up for that. And also with the metering, one thing I think that's missed here, and this is where you need to work with the electrical engineer, is that there's 2 types of metering at a site. So there's your secondary metering, and that's built onto the transformer. And then there's primary, and that's typically done on the pole level, and that's on the high voltage side. Depending on the size of your site, you're going to either want to do secondary or primary. If you're doing 2 to 5 megawatts, you want to have your meter on the transformer. You're going to save transformation losses more than anything. But it's, again, rely on the electrical engineer at the co-op level, because the high voltage equipment, you don't want to be responsible for the power company's power grid. And when you do that, you get into being responsible for their power grid.
Understand.
Yeah,
So,
that's my opinion, at least.
Can you explain to us a little bit about oh shoot, I just lost my train of thought. What was I going to say? It totally I lost it, guys. Ethan, do you have anything to add on to what Jason said?
I think you're going to ask something about power and electricity.
Thank you, Scott. Appreciate that.
Yeah, to what Jason said, I mean, he's right. It comes down to the utility. It's you're going to have to do a load study. Because I mean, really, your biggest variable in all of this anyway is energy rates. And so the first place to start is you got to do a load study. Like, you got to know how much power that they can actually bring you, and then hopefully you're negotiating power rates. Where a lot of people get hosed is you're like, yeah, I want to mine Bitcoin, but you're at 13 cents a kilowatt hour. Well,
yeah,
you're not going to be very profitable. So you're just wasting money and hoping to make money. When Bitcoin's at $100,000, a Bitcoin, that's not the way to do it, right? And so you want to get that cost down. If you can be in the 5-6 cent range, that's kind of the big guys right now. We were talking to Clean Spark yesterday, and they're they're looking for sites in, from anywhere from 4.7 to 5.8. That's kind of their range, right? So if you're mining 1 or 2 megawatts, you may expect to pay a little bit higher than that. You get up in the 8, 10, that, it's not as, may not be very profitable, right? So that's important, metering, you're probably, one thing I would recommend, I mean, regardless, and this kind of goes to, once you have the load study, I would highly encourage you to do engineering. Even if you're at a, 1 megawatt site, I mean, think about all the miners you're spending. It's a big capital investment just to buy those miners. For a small 1 to 5 megawatt site, you can get stamped engineering 1 mines for, anywhere between, $5,000 to $10,000, right? And it's worth it for many different reasons. One thing is just, coordinating with the utility. The utility has their utility recloser, there's fusing upstream. If you don't coordinate your site with their site, then what a lot of times can happen is you can have nuisance tripping. And then if you nuisance trip that utility, they can shut you down. Like there's stuff in your contract where, man, you keep blowing our site up, we're not going to provide power to you anymore, especially if you're, not consuming very much, right? Yeah. And so just making sure that what you have on your side coordinates with theirs and you're not tripping the site. That's pretty important. So, the other thing engineering does is when you go build this site out, I would say 99.9% of all sites that I've been involved with cost way more than they budgeted. Everyone wants to say that they can do it for way cheaper. But a lot of people, they don't do engineering. Well, if you don't have engineering drawings, you can't hold the contractors accountable to anything. So when they go in there and they just pick a wire size and say, well, that's what, Joe Bob, the electrician. So I'll say this, not all electricians are the same and not all PEs are the same. Just because they, are a master electrician doesn't know they've built that doesn't mean they built a Bitcoin mining site, right? And so, unless you have those documents that you can hold them accountable to, it's tough because then they're, I just did what I thought, right? Versus actually like, no, this is the actual design and you need to go fix it and it's on you. So.
What is the best way to, get that message across to your engineer or your master electrician? Maybe they don't understand Bitcoin, but maybe they've built data centers before, which is very similar. So how do you find, like, let's say you're in a small local jurisdiction, in the middle of nowhere. How do you find that master electrician? Do you fly them in from somewhere else? Do you, speak with your electrical company?
I think you can find it. I mean, there's plenty of engineers, and I have a bunch of them. I'm sure Jason has some as well that have built these sites out, and so they don't have to be there. They can just kind of keep that electrician accountable by having that set of 1 lines. But I would encourage find someone that's done it before. Sometimes if you go get an engineer that's never done it, 1, they may charge you a bunch of money, and 2, they're gonna probably, if they go based on a traditional data center, they're going to over-engineer that thing and it's going to cost a lot.
Yeah.
That's what, like us as equipment manufacturers, we like to work hand in hand with the engineers, because in the end of the day, like we want to sell our product, but we understand Bitcoin mining is very cost sensitive. So we want to get them the fastest, cheapest solution that's compliant, that meets their needs.
Understood. Chester, you had raised your hand earlier. Do you want to go ahead and ask that question?
Yeah, I was going to ask. I mean, you mentioned Clean Spark and their cost per kilowatt hour. What is because I know they're doing a bunch with curtailed renewables and flared sites. Do you work in that space? Do you see any of the power rates that those guys are getting for absorbing renewables that aren't being spent?
That's a good question, honestly. So we have a whole division, Moonshot Energy. Brian Lubin is the COO of that division, but that's probably more of a question for him. For me personally, what I've seen of it is more of the, just grid power. That's what we've been focused on.
Grid tied.
Yeah, but Brian could probably talk more to that. I don't know if Jason has any comments.
We're doing so. I mean, with here, I think one of the things that's kind of misunderstood is Bitcoin is a great curtailable, and this is in my experience with on-grid. Bitcoin's a really good curtailable load, but in some places right now, I mean, it is literally a requirement of having that kind of power demand to be a curtailable load. So it's not even, some power co-ops and companies are not offering very attractive rates to curtail. It's literally a matter of being a user within the community that you're choosing to put your business in. But for the off-grid stuff, we have a development we're doing in South Mississippi. We're going to have up and running in about a week. We'll be live on Friday. And with that one, I mean, I want to say all in with our generation costs are about 5-6 cents roughly. But I mean, it really depends on the site and where you are. But I mean, we're direct on the pipeline. I don't do any of the, oil and gas well stuff. I have no desire to go get muddy all day. Did that for 2 years. But it really, again, it varies so much based on geography.
From like the transformer setup, and you're grabbing power from the grid. Like if you are looking to build something, just to give you some context, I know we're 1 to 5 megawatt, but I'm looking to do a 50 kilowatt project here on my property that's partially grid tied, and so I want to be able to have some visibility. How much I'm using kind of behind the meter and how much I'm selling back to the power provider. But like, can you speak from an equipment perspective if you're going to be participating in any of those? Do you have a bunch of different engineering challenges? I mean, at scale, I mean, 1 to 5 is probably a much higher scale, but
Ethan, I'm gonna let you run with this one. I'm still thinking here.
I mean, as far as like, metering, really, I mean, you can get meters on anywhere from the PDU level, right? So I got a client, they're putting meters on the transformer. We build meters into our switchboards and panel boards. So, one thing I would say to that is just make sure that you have a meter so I'll give you an example. Okay. We sold 2 transformers to a client, and those transformers, they got a test result back 6 months later, and they had high levels of hydrogen. And so that hydrogen gas, also the temp gauge was at like 95 C. So that meant that those transformers overheated. And they said, well, our system is only set up and we can only be running those at 2 megawatts max. And those are 2,500 kVA transformers. And I'm like, okay, send me the data. And so he sends me the average kilowatt hours. Okay, that's great. But there's this thing called power factor. Okay. And just because you're pulling, kilowatt hours, that's how you bill, right? But you also probably want to check the ampacity, so you see what the actual load is. Because if there's issues, you want to be able to go back to the utility company or the transformer manufacturer and say, hey, I was running these, like this was the actual load. Here's the data. So you can kind of hold those guys accountable. But, basic meters, I mean, it's not that expensive, but you can go add a meter for, $3,000 onto some equipment. My client, they're putting it on the transformer. I forget the name of the meter that they use. I forget the name of it, but anyway, it comes with CTs. You get those Rogalski coils. They can go around the phases and the neutral, and then you can monitor it with that equipment. I think an E-gauge is what they're using.
Mm-hmm.
So.
And I mean, really with the curtailment too, the metering, everything's huge, but the curtailment, there's a lot of great software tools out there that will curtail your miner load. I mean, almost instantaneously. I used to, when I had 3 miners running in an office closet. This was years ago, and they were all running Hive, and literally I could control the entire mine from my phone anywhere. And you can cut that load down to, I think it's almost 5%. almost instantly. So I mean, there's a lot of ways to do it. Just like Ethan was saying, though, I mean, the metering where it's very useful is you have data points on how, not only on the engineering standpoint where if something goes wrong, you can analyze it, but also from like an accounting and financial standpoint. I mean, you know where every single loss is in your business model. And I mean, even at a megawatt or 5 megawatts, knowing exactly how much your losses are is huge. But at some level, you're operating a mini city essentially is what you're responsible for. So you think about it in that scale and then realize you're a service provider as well, in addition to running a data center.
Mhm. Yeah, and there's different accuracy meters. So I think for like I'll use oil and gas, like a custody transfer. If I'm selling back, like a billing meter, you're going to want to be at like 0.5% accuracy. So the cheaper meters are going to be like 1% accuracy. So
100%.
So this might be a novice question, and it's coming from someone who's a novice and has never built anything like this before, personally. But what is the major difference between pole mount transformers and pad mount transformers? Obviously, one's on the ground, one's on the pole. And when do you have to go from one to the other? Like, do you only use pad mount transformers in a 5 megawatt build? And then also, could you explain the difference between single phase and 3 phase?
So with the transformer, with pole mounts, I have seen very weird sites in Kentucky, for example. There was one that was a 1.5 megawatt site, and that was purely pole mounted transformers. It was strange. I'm a big fan of pad mounts personally. Everything's buried. It's very clean looking. Bottom line is too, your site logistics are easier, I think, because you're not worried about wires everywhere. Most of the time you will be pad mounted, and it's a safety concern, but also when you think about it, you could probably do pole mounts up to a certain size. Again, 1.5 megawatts pole mounts is very odd.
I didn't know they made them that big.
It was, they put 5 of them on. So how this was structured, they had 2 poles, and then they had 4 500 kVAs.
Okay.
Mounted in the air on wood. So, I mean, there's probably 10,000 pounds, 20,000 pounds just in the air above your head. And I mean, I always think about, all right, if there's a tornado or a windstorm, what's going to happen there? With the pad mounts, I mean, they're there, they're not moving anytime soon. So, I'm a big fan of the pad mounts. I think the cost is pretty negligible when you look at the cost comparison between the two, but again, really, it's safer for your electrician because someone's got to run the wire from that pole mount into the mining container, and it's safer to do it from a pad mount because you're all underground most of the time. So I mean, again, but at 5 megawatts for cost savings, I mean, you're probably be, Ethan, correct me if you disagree, but you'd be at 3750 and a 2600 more than likely to hit 5 megawatts on the dot. Unless you had some strange power company that said, no, you can only do it this way. So that's pretty much it on, yeah. And then with single and 3 phase, again, it's just down to engineering work.
Okay. So explain to me, would it be better? Let's say, yeah, we're building out a 5 megawatt, but with the intention of possibly expanding over into the future, going up to 10, 15 megawatts. Would we want to make sure that our transformer is sized appropriately for the 15 megawatt build that we might do in the future? Or do we want to size it for the 5 megawatt build that we're doing currently?
So I'll speak to this. You can get really big, 5,000 kVA transformers. One's going to be really expensive, but 2, it's going to be really tough to make that site compliant. The bigger the transformer, the bigger the kVA, the higher the available fault current. And to be within code, there's this thing called, we can talk about arc flash and all the stuff, but the SCCR rating, short circuit current rating, okay, which is basically the amount of short circuit force that equipment can withstand without like exploding and killing people. Okay. And so per code, all of your equipment downstream or on the load side of that transformer needs to be at a SCCR rating greater than the available fault current. So when you get these really huge transformers, that means you're looking at, so there's a couple factors. One, it's hard to get equipment that's over 100 KIC. It costs more money, longer lead time, right? And so you complicate your system by doing that. Kind of the sweet spot is the 25, 50 kVA transformers. That's usually what I recommend, and operate them at 80%. Why 25, 50? Well, 2500 and below, they have to be rated by the Department of Energy or the DOE. And so if you do 2550, they don't have to, so that reduces some costs. Actually, a 2000 and a 2500, the 2000 may cost more than the 2550. If you think about doing 10 megawatts, the other thing I would look at on my transformer is if you're looking to expand, what a lot of guys do is they loop feed. So if you loop feed, that means you want to do loop fed transformer with like 600 amp bushings. So that way you can kind of daisy chain your feed, and up to 10 megawatts. Now you start getting bigger, you're in the 15, 20 megawatt, from one utility line coming down, you probably don't want to loop feed more than 5. I mean, 5 is probably the most that I've seen loop fed. And so then now you're looking at switch gear. So there's switch boards, those are low voltage, 600 volts and below. Switch gear is on the primary side of the transformer. So switch gear is going to take that, 24.5 high volt or medium voltage line. It's going to bring it into switch gear, and then there's going to be breakers, and they may only be 300 amp breakers, but 300 amps at 34.5, right? That's actually not as much ampacity. There's not as much ampacity when you're that higher voltage, right? And so you go from that switch gear, and then you're going to feed sets of transformers, maybe a set of transformers that you do loop fed. So not that answers your question.
It does, actually. It answers it quite a bit. So no, that's good. Good stuff is happening. So I want to talk a little bit about the actual cabling that goes in the ground. I've heard, and Jason, I think you're the one that told me this, aluminum works well. There's also copper. Copper's more expensive. I want to talk about the trade-offs between the two and the expense that can be incurred over long distances of cabling.
Yeah. So just to kind of, I don't want to say clarify the difference between the two. Aluminum has a lot of vibration. It's a higher resistive load. I mean, there's more resistance on that aluminum, so it's hotter. There's more maintenance with aluminum. There's a lot of factors that are more maintenance oriented, I would say. Copper is going to run cooler. There's less vibration, of course. It's more stable. I mean, there's a reason copper is everywhere. So aluminum for this industry is a lot cheaper, but it's also, there's more cost to it because you have to retorque bolts on a regular schedule. There's a service interval. So you're saving money up front, and it's really cost benefit analysis with most places. But also engineers are your go-to. I mean, this industry, we're running a small city at any site. So if the engineer is telling you, hey, we're doing copper on this load, he has a reason to do it. And you have to just make the expense at some levels here. For example, like our off-grid site, I talked to the engineer, and I'm a big fan of copper for this one because we know we're going to have downtime, and us having a planned generator service day and also having electrical cabling service day at the same time scheduled, it's very easy to do for us. But it comes down to a matter of, what if something happens in between maintenance events? How can we be the most resilient we can be, and how can we eliminate issues across the board? So that's where we relied with the engineers and not purely looking at costs, because everything comes down to safety at the end of the day. Again, fire events, anything like that can be avoided, but they do happen. So anything you can do to prevent that from happening is massive.
Yeah, one of the things to add on to what Jason was saying, you guys can go Google NEC ampacity chart.
Yep.
I look at that table all the time. And so you'll see, if you want to operate at, 500 amps, you may be running, and you can maybe run one run of cable or maybe 2 runs or even 3 runs of aluminum, based on the ampacity. You can go look at that chart. But, I would always encourage, use the 75-degree table. That's derated. Your engineer may even have to derate it. Once you bury that, there's additional derating. There's been many sites. Actually, I was talking to a site the other day that they unburied all of their cable and it was welded together. Even traditional data centers, this happens, right? There's different types of derating, like the soil condition. Like the way that the soil is determines how you'd have to derate that cable, how many cables per tube of conduit that you have. And so a lot of that goes, people think, oh, I could just run, 2 runs of aluminum is cheaper than 1 run of copper. Okay, well, now I got way more cables. So now I need to make sure I space those cables out. So that means I need wider cable tray. I need more conduit. And so a lot of times you may think, oh, I'm saving money, but you may not, because you're not factoring in all the other things that are associated to making sure that's successful solution. So
Exactly.
Awesome. Yeah, definitely. I mean, we're big components here at Bitcoin Mining World to do it right the first time. That way you don't have to do it twice. And if you have to spend a little bit more up front, it seems to me a better idea than just having to come back, redo things, deal with fires and stuff like that. And on the topic of dealing with fires and other things that can happen, why is it necessary that you properly size your transformers, switchgears, PDUs, electrical components up to, I think is it 80% of what it can be what can be done on the units themselves?
Yeah. So one thing I want to highlight, and I didn't bring this up in the hosting conversation, but I think it's important here, is and this is before we go into this, is on a miner level, you can size out your PDUs for 80% of what the miner should do nameplate. No matter what, you should always do that and size it properly. But if you allow your clients to go and overclock their machines however they feel fit, they are not going to be thinking about your PDU ratings and your safety ratings and your engineering components. So I've seen sites that will allow their clients to just hop on, overclock the machine real quick, and it's good to go. But I think anyone that's tried overclocking or third-party software knows that power load that it provides is not accurate. It's normally off by about 20%. So first off, that is the one aspect I recommend having as a policy, aside from sizing everything properly. Just make sure you're monitoring what the machines are actually consuming.
And you're doing that at the PDU and distribution level?
No, it's literally not allowing people to have free reign over the performance of their machine. Because I know there's clients that require VPNs. I've seen it before and I've had to say no. And it's a safety matter, not anything else other than that. And then Ethan could talk about the sizing because he sells more PDUs than I probably ever will. But that's just one thing I've experienced that is critical.
yeah, absolutely. Yeah, I mean, when it comes to sizing, I mean, typically, starting with the transformer, you want that transformer a transformer goes down, your whole site goes down. So generally speaking, that's where the 80% starts. I mean, can you operate those at 100%? Yeah. You can, but depending on where you get, there's better transformers than others. There's stuff that you can get out of China. You go down to the core steel. It's not the same quality as if you get, more of a name brand, transformer that's built in Mexico or Philippines, right? And so, to allow your equipment to last long, you want to be about the 80%. When it comes to the rest of the distribution, you can get panels that are rated at 100% rated, so you can run them all the way up. As long as you have that 80% somewhere in your system, that's really what's important. But sizing breakers appropriately, understanding, if I'm going to design a system, one of the first things I ask people, and you could go to a lot of different distributors and they don't understand Bitcoin mining. They don't understand what they're trying to accomplish. Like what I like to do is like, what are you trying to, someone may say, give me a 1200 amp panel. And I'm like, all right, tell me about your PDUs. Tell me about your load. What miners are you using? What's the maximum load, right? And then we can help design a system that's going to accommodate that. But if you have, thermal mag breakers, okay, basically they're taking thermals, and basically when it hits a certain temperature, right, there's metal in there, right, it actually expands, and that causes that breaker to trip. Does that make sense? And so if you're using thermal mag and then you're air cooled and you're 105 degrees outside, what that's going to do is that breaker is going to actually derate anyway. So you may be tripping at, 70% versus 80%, right? So it's important to understand like what your maximum load is, where the service is going, so that way you have a system designed, to meet the demands of, what your load is.
Absolutely.
Awesome. Thank you for that. Hey, Tim, you had a question. Is Tim still in here? All right. Well, if Tim, if you want to put your question in the chat, we'll get to it. But I want to move on because we're getting to the end of this. I want to move on and talk about processes and techniques that we can adopt to make our operation more efficient, more effective, and what can we do to make sure that we don't have to maintain, or we don't have to maintenance the electrical infrastructure all the time. Obviously maintenance is important, but what things can we do? Maybe it costs a little bit of extra money, but what can we do to make sure that we're doing a better job at installing this infrastructure?
Yeah, I'll go back to the beginning, engineering. Think about, what do miners cost right now? I don't even know.
4,000, 4 to 5,000. Unless you're in the Caspi units, then you're buying a car each unit. But
so 4,000 to 5,000 for a small operation, for the cost of 1 or 2 miners, you can actually have engineering done, stamped engineering drawings, arc flat. I would encourage people to do like coordination studies and arc flash studies. It doesn't cost that much. I got an engineer that'll do it for pretty cheap. He's doing a 200 megawatt site. I want to say he's like $20,000 for 200 megawatts, and he'll print off stickers, and the stickers say, here's the appropriate PPE required. One of the big things for us is just safety, because you guys are, like Jason said, you're operating a small city. And so if there is an issue, you're liable for that. If you didn't do engineering, if you didn't follow NEC, if you don't have the proper equipment in there, right, you're liable. OSHA is going to come and say, hey, how come this happened? I went to a site a couple of years ago. We built all the gear. I showed up and all the 4,000 amp gear was sitting in water. And the guy's 6-year-old son was riding around on a scooter through the puddles with the switch gear and the grounding and the neutral. They didn't bond it right. The cable was like purple. Luckily, the site was curtailed. I was like, I'm not going in here, but it was curtailed. And so, what you want to do as a site owner is you want to push that liability as far away from you as you can, right? If there's an incident, they're going to say, do you have a one line? Do you have, what's the required PPE? Do you have the safety plan? All of those things, right? Do you have the proper labels on all of your equipment? So that's, from a liability standpoint, one incident that could cost you your entire operation, and then you're shut down. And the utility says, we don't want to work with you. I've had I was working with an engineer up in Oklahoma, and they told this group was working with Oklahoma, I forget whatever the power group is up there, but they blew up the site a couple times because they didn't do engineering on the front end, and the utility company said, we're never going to work with you ever again, and basically like blacklisted them from the state of Oklahoma for doing sites. And so, it's important. The cost of like 1 or 2 miners, and you save yourself thousands. I mean, imagine like not running for, like, what if you get shut down for a couple weeks? Like that cost right there, right? So think about it. Be willing to invest on the front end. It's going to save you a ton of money, headache. You don't have to worry about like, what are my liabilities, because that's pushed away. That's on someone else. So
yeah. And I mean, adding to Ethan's point here on the PPE side of things. I mean, I was energized at one point, and the only reason I'm here right now is because I had I still have the boots actually, but I had my, OSHA PPE shock rated boots. And my tap tester I was working with said that it was a dead circuit. The electrician came back the next day and said, hey, this is live. So things break. You will have tools that are safety tools. You need to test them all the time. I learned a lesson there because he told me that. I was like, wow, that makes sense why my back hurts today. That was it. But that was a 480 volt circuit. So PP and all those things are probably the most underrated part of this industry, I think, on a small scale when you're from this 1 to 5 megawatt range. And honestly, I don't think there's enough attention around it. That's my 2 cents on it. I'm sure Ethan agrees. And that's something that cannot be, just undervalued by any means. If you look in the oil and gas industry, I was in the hydrogen business for 2 years. There's not a single person on a site without FRs on if you're on a wellhead. And it should be the same way when you look at Bitcoin mining, honestly, because you can, arc flash happens, bad things happen, but protecting your staff in any way possible is critical. But it's also protecting yourself.
Absolutely. George, Pate, you had a question. Go ahead and unmute yourself and ask.
No, I'm just thanking y'all for all the knowledge and for being here, and Scott and y'all for putting all this together. Thank y'all so much.
Absolutely. We're thankful for our speakers today. They jumped in and did this very last minute. So thank you guys. Well, I guess at this point, let's go ahead and open up the conversation to anyone else who has any questions that are related to electrical infrastructure. And we'll just, spend the last couple minutes fielding those. So George, you just raised your hand again. Go ahead.
Gliptol. Tell me about Gliptol.
What is Gliptol?
What is Gliptol? That's what I need to know from the electrical guys, and just let everyone know what it's used for and to look out for it. If it's not being used on grounds and whatnot for corrosion protection, we probably should be watching out for a lot of this.
I'm having to give this one a Google here because that's outside my wheelhouse. You said Liftol?
Gliptol. It's a red sealant that's used on grounds to prevent corrosion. I just learned about it here recently, and I didn't realize it was used in motors and a lot of other things, as well as electrical applications.
Yeah, I know we've site that we built. I know I don't know if that's what they were using. I know they put some stuff on the aluminum conductors for sure.
Yeah, you have to.
But and I'll be honest, I sub out a lot of that stuff to electricians. So when it comes to that I let those guys handle it. So
that is also a thing I sub out as well. But again, it comes down to, as Ethan said, spend the money on engineering. They will have a spec on how it's built and how it's constructed.
And what about like getting different quotes, like in different engineering standpoints? Do you agree with like bringing in someone to check work, or do you like think on more of the side of too many cooks in the kitchen?
Yeah, there's consultants, when I build a site, I mean, that's kind of packaged in there because there's stuff that we'll do, and then, we're going to subcontract out a lot of that. And I want to have a third party inspector. The worst thing is you go build it and then the customer has a inspector, or the utility comes and says, hey, this isn't to code. Because a lot of times you don't know. All you give a contractor a set of drawings. How do you know they did it right? Other than, yeah, I did it right. So it's good, you could probably pay someone a couple $100 to go out there and just go check through your site to make sure that it was built to the drawings,
Absolutely. And one thing I will say is, like when I've picked electricians, when I've been on grid projects, it's typically from a referral from the power company themselves. And I recommend that, because if the power company is referring someone, it's someone they've worked with. So there's a good working relationship there. They're going to be compliant with one another. They're going to communicate with one another. They're going to, serve you the best way possible. But also, when your site becomes energized, make the electrician energize it. Like, make him be the one to touch the switchgear. It's his work. And I mean, really, it's turning it on. It's their trade. It's what they dedicated their life to. And having them be the ones that are hitting on your mains, energizing the site, the whole 9 yards. Not the mining side of things, that's your job, but in terms of actually energizing the switchgear, make them do that. And if someone doesn't want to do it, there's a reason. Because I'll just give you an example. Like Mississippi, our state is not an NEC required state. It's on a county by county level. And for it to be enforced in the state, it has to be voted on by the county. So we have rural counties here that actually do not have NEC requirements by any means. At that point, you are the code. What I mean by that is everything that you enforce is corporate standards that have to be enforced. So that, I imagine that is in other states. I cannot say yes or no if it's not, but I mean, you literally cannot have enough inspection.
Definitely agree with that. Chester, you had a question, and then William, if you still have your question, you can ask after Chester.
Yeah, my question was, you had mentioned earlier, just kind of a miner who like screwed up a site, caused some bad blood with a grid operator. Do you see operators, or grid providers kind of like getting a bad taste in their mouth for Bitcoin mining, and just being, having certain jurisdictions be anti-Bitcoin mining? I mean, we have this from an environmental perspective on flared well conversion projects with like local, statewide, like in Pennsylvania here, we have the DEP, and there are certain counties where like you can't put a mine because the regulators are like, we don't want to deal with you guys because people are cutting corners and they're not doing the safety stuff. They're not getting air permits. They're not doing site surveys or modeling, or, and just avoiding the engineering stuff like you were mentioning. Do you see that too for the power side as well? And like, is there like a list of jurisdictions that are like more sensible or more nuanced, kind of take each operator as they come, or what are your thoughts?
Yeah, a lot of it, I mean, it becomes a political issue, I mean, that's why you have like Texas Blockchain Council, and they're kind of like the lobbyist group, if you will, for, the mining industry in Texas. And so, it is a lot of it's county by county. You get some mayor in there that, a bunch of people complain. And so it's important, especially if you're going to be near, residential, to make sure that you guys get the approval. I've heard sites get shut down because of, they had the decibels were too high.
Noise
right?
audits, yeah.
And so that happens quite a bit. So, you got to think about it. You also need to be a good ambassador for the industry. And so that's making sure that you're doing things right. You're communicating with the city. Now, if I'm requesting power, sometimes I may say it's for a data center, not necessarily Bitcoin mining, because I don't want the red flags to come up right away. And then just shut it down because they heard something negative, right? So I may approach it from a, traditional data center standpoint. But, eventually, I mean, really what it comes down to, I mean, if you're a good steward of the industry and you treat people right, and you think about, hey, what could, is there sound issues? Is there some compliance stuff? And you just do things the right way, then people will appreciate it.
Yeah. And I mean, adding to Ethan's point, power, like the actual amount of power on a grid in an area is also an economic development challenge. If you build an industrial park, let's say, they might have 200 megawatts available. It might be a 300-acre industrial park. For the community you're building in, it might be a bad decision for them to say, hey, we can give you 100 megawatts as a Bitcoin miner, because you're going to have what, 20, 30 full-time jobs maybe. And that's something that not even the power company, but literally just the community, the government, the permitting, all those people are going to be conscious of, is that, okay, we can allow a Bitcoin mining facility, but that might cost us having I don't know, just an example, a Nissan plant come in that's going to create 2,000 jobs. And those are all things that can affect you. But one thing that is underrated is that noise pollution is actually considered a form of pollution.
Yeah.
By the EPA. It is considered a form of pollution. So
yeah, we're seeing permits get yanked because of environmental justice concerns due to noise.
yeah, and I mean, it is pollution though. I mean, I've seen a bird fall out of the sky before. The heat wave of the miners, like things happen. But again, it comes down to, we run data centers, so there's a cost with being in business.
Awesome. William, go ahead and ask your question.
I was just gonna say, I dropped the aluminum no locks is the stuff that you use on the aluminum connectors. I put that in the chat for everybody if you want to use it, because that's what I got for my site. And I'll just say I worked with Jason to get a transformer getting here soon, but I'll tell you, I talked to my co-op and their engineer was more than happy to bundle in him doing all my engineering, all the drawings and everything, and them dropping my 3-phase over. Cost me $225 extra to have all the engineering done by the engineer from the co-op. So, that would be where I would start. I would start with whoever your provider and say, hey, do you got an engineer that you guys provide this service for a fee? Because it was like $1,000 for the 3-phase to get rolled over to my site from the wires. And then they charged me like I said, like $225 for him to do all the engineering, do the drawings. He said I sent all the drawings Jason sent me for the pad and for the transformer and everything to him, and he took care of all of it. So that'd be a good place to start, I'd recommend.
Mm-hmm.
Exactly. It's rely on the experts that are employed by your power co-op, literally. I mean, William's site, for example, it's a great site. I've worked with him closely, and it's just working with the experts that you have available more than anything.
I will say I'm still going to have an electrician come in after because I'm connecting everything up myself. I mean, I've worked in the nuclear power industry for 30 something years. So I got experience, but I'm still going to have a guy come in and paying him to do my second checks on all my connections to make sure they're all good before we power on the site. So.
Awesome. Thank you, Wilbert or William. If anybody else has any questions, go ahead and raise your hand. We've got a few minutes left, so I want to get as many of you guys' questions as possible. In the meantime, Richard did ask a question.
Trevor, you're muted.
Yeah. So Richard's question was, eventually sometime soon, I will be moving my residential 100 amp 24 kilowatt mine to one of my dad's properties in rural area. What are the primary topics I need to educate on with setting up a 2.5 megawatt transformer? He says, we have access to electrical poles on the actual property. What topics do I need to look into to help me decide if I want to run power from the transformer level or pole level?
Well, 2.5 megawatts, right? What you said. So if you're going to you're going to probably want to get a pad mount transformer. Yeah. So definitely not pole mount. That's going to be just like Jason was talking. That was a crazy setup.
I'll send you a picture, Ethan. Like it's nuts.
I can't believe that. I was like, yeah, never, but that's crazy.
I've only seen it in China. Like literally, that's the only place I've seen them do that before.
Yeah.
I mean, on that again, it comes down to the utility. If you're doing a load that large in a rural area, I mean, you're running a humongous load for a community, and if you're in a rural area, it's gonna be a big load on the power line. So you have to. I mean, it's gonna be whatever that co-op engineer or power company engineer tells you they need you to do. I mean, I'll give an example is that there's a hotel in the town I live in because I look at the transformer every time I park next to it. And it's a 4-story building with 2 restaurants in it. And I think it has like 70 rooms or so. And that's running on a 500 kVA transformer, just to give you guys the sake of comparison here. So you have 5 of those on this grid you're setting up on a farm. So it's critical to trust the co-op electrician. Let him tell you what they need, and then everything that's from the transformer to the container, and from there, find an engineer. You can talk to Ethan or myself. I know Scott knows engineers. Trevor probably does too, and let them work with the power co-op engineer and do their job and figure out what's best for your movement forward.
Absolutely. William, question? Go ahead and unmute yourself.
Oh, no, I'm good.
Oh, okay. All right. Well, it seems that is everything for our call today. I just want to say, Ethan, Jason, thank you guys for being here today. I really appreciate your time and the information that you shared with our community. So that was absolutely amazing. I know that it was short, it was last minute, but you guys came through for us, and we really, really appreciate that. So real quick, guys, I'm gonna pin myself to the top here. I'm going to share my screen. I want to tell you guys about our here. I want to tell you guys about our mastermind. So our MasterMined Club, this is kind of part of what our MasterMined Club is. We do the deep dives, which we open to our community. But if you join our MasterMined Club, you actually get access to our backlog of deep dives. You get access to minimum order quantities, special time with Scott and the rest of the team. If you want to get in contact with these engineers, if you want somebody to hold your hand throughout the entire process of building your mining operation, joining our club is one of the best ways to do that. We meet weekly. A lot of our members, have questions regarding their operations, their mining situations as they go. And so being able to meet weekly and ask those questions to knowledgeable people who have the access to even more knowledgeable people is very, very important. So I implore everyone who's on this call today to take a look. You can go to Bitcoin Mining World and sign up there. It's $100 a month, and you get access to so many things. So for everyone who was on the call today, appreciate you joining our community or coming in and being part of our community. So you were able to watch this, but if you want to be able to have access to the recordings or our past recordings that we've done, you do need to join our group. So yeah, that's just a little bit of us. And Scott Offord is a really great guy who's put everything together. He gives opportunities to the smallest of people to build out and create your dreams. So definitely get in contact with him if you want to find out more. But I appreciate everyone for being on the call today, and I think we'll wrap it up there.